Okay, so here's some videos that I promised to make on a couple of questions from factoring from the study guide. So here I'm starting with number 1, which is factoring out the greatest common factor. So I'm going to take a look at this first one here. 3x to the 5th plus 4x to the 4th minus 5x squared. First, we want to look at each of these numbers, 3, 4, and 5. There's not a common factor to pull out. So then I go to my variables. I have 5x is here, 4x is here, 2x is here. And we had said that the GCF for variables is the one with the smallest exponent. So my GCF for this problem is only x squared. So I'm going to set it up where I have my x squared in front of the parentheses. So I'm going to take that now and divide each of these terms by x squared. So when I divide, I have 3. What happens when you divide with exponents? You subtract. So 5 minus 2 becomes x to the 3rd. Plus, for the middle, 4 comes down. X to the 4th divided by x squared. I subtract those two exponents. 4 minus 2 is 2. And then for the last piece there, my x squared divided by x squared cancels. So all I'm left with minus 5. So there is my answer for the factored form for the first one. Let's go ahead and do the second one. Second one says 6b squared minus 12b to the 3rd minus 18b to the 4th. Let's take a look at the numbers, 6, 12, and 18. The highest GCF there is 6. They all could be divided by. I take a look at the b's. I got b to the 2nd, b to the 3rd, b to the 4th. The smallest power is b to the 2nd. So my 6b squared is my GCF on the outside. I'm setting it up. Now I go back and divide each of these by 6b to the 2nd. Let's go ahead and divide. 6 divided by 6 is 1. B squared divided by b squared cancel, so I'm left with 1 minus 12 divided by 6 is 2. B to the 3rd divided by b squared. 3 minus 2 is just b to the 1st. And then 18 minus divided by 6 is 3. B to the 4th divided by b to the 2nd. We subtract the powers, becomes b squared. So there is my answer for the second one. All right, taking a look at factoring quadratic polynomials. We know it's a quadratic because it's got x squared there. We had 2 types where a was 1. So the first one there, my a is definitely 1. It's the x squared plus 44x plus 84. So we are looking for factors of 84. And they have to add up to positive 44. So most obvious is 2 times 42. Because at the same time they add to 44. Because it's x squared, I gotta put x and x. And then I'm gonna put my 2 factors, positive 42 and positive 2. And you could actually check to make sure this is right by multiplying my inner terms. 42 times x is 42x. My outside terms, 2 times x is 2x. These are added up to give me my middle. So we know this is the correct answer for that one. Now, the second one there is different because my a is 7. It's greater than 1. So it's a little different of a process. That's that slide and divide method that we did in class. So I'm going to write it down, 7x squared minus 9x plus 2. What's different about this is I have to find factors of 7 times 2. So I'm finding factors of 14 that add to negative 9. So both have to be the same sign. It's going to be negative 7 times negative 2. That will give me negative 9 when I add. Now, how do I do this differently than the first one? Well, for the slide and divide method, I am still going to set it up the same way, x and x. I'm going to put my 2 factors, negative 7 and negative 2. The only difference here is that I need to divide by the a value. So I'm going to divide by that 7. If I can divide it, I go ahead and do so, which is this first one. I cannot divide this 7 into 2, so it's going to come in front. So it becomes 7x minus 2. And there is my answer for that one. And again, you could check by multiplying inner terms. This is negative 7x. Outer terms, negative 2x. And when I add that together, I get negative 9. All right, now let's go to the last one. 5x squared plus 11x. Oops. Five x squared, what was it again? Plus 11x plus 6. Okay, here my a is 5, so different than the very first problem. So I'm going to do 5 times 6. I want factors of 30 that add to 11. Okay, so 5 times 6, I think that's pretty obvious. Still setting it up the same way, x plus 5, x plus 6. Only difference is because I have the a being 5, I have to divide both of these by 5. The first one can be divided, x plus 1. The one over here, I can't divide that 6 by 5, so that 5 is going to go in front, 5x plus 6. And again, I could check, this is 5x, the middle term. This is 6x, and when I add it, I get 11x is what we have to start. So this is my answer for the third one. This was my answer for the second one, and now we got the answer for the first. All right, this is just like what we did above, still factoring quadratic polynomials. What are 3 different values that complete the expression x squared plus what? X plus 42, so that you can factor it into the product of the 2 binomials and show your factorization. So we're going to list our factors of 42. All right, let's start with the easiest one ever, 1 times 42. So they are all pluses in this equation, so it would be x plus 1, x plus 42. Question is, what is that middle value there in front of the x? Well, think about it. 42 plus 1 is 43, so the middle value should be 43. So here's one set. That gives me 43x in the middle. All right, second set. What else is factors? 2 times 21. So when I put it in, x plus 2, x plus 21. So this is going to give me what in the middle in front of the x? 21 plus 2 is 23x. So these are the 2 values, and that's what the x value would be. They want one more set. So what else are factors of 42? 6 and 7. X plus 6, x plus 7. When I write up my thing, what's going to be the number in front of the x here? Well, 6 plus 7 is 13. So 13 is going there, and those are the values. Okay, now we have factoring special polynomials, FSP. The first type is difference of squares. So if you remember the formula from the note catchers, if I gave you something like this, it factors into a plus b, a minus b. So we need to do the reverse of what it says for this example here, t squared minus 100. So we want to know what would multiply to get t squared. Well, that's t and t. What multiplies to get to 100? 10 and 10. So when I set it up, my factor form is going to be t plus 10, t minus 10. On the back of the page, still factoring special polynomials. This is still difference of perfect squares for this one. Y squared minus 49. We got y and y. 7 times 7. So when I factor it, it's y plus 7, y minus 7. for this one here, b squared, b to the 4th minus 4x squared. This is still a difference of perfect squares because we have 4 would be 2 times 2, x squared would be for the x, and what would I need to multiply to get b to the 4th? It would have to be b squared. So when I set up my factored form, it's going to say b to the 2nd plus 2x, b to the 2nd minus 2x. Last special polynomial one here is n squared minus 18n plus 81. Now, it actually is a special polynomial. It's a perfect square trinomial, meaning that we know this is n times n. This is going to be 9 times 9 for 81. And we want to know what factors or sign does 9 have to be that I get negative 18. They both have to be negative 9. So I'm going to have n minus 9, n minus 9. You could leave it like that, or you could write it like this, condense it with square. I'll take either answer. If that one's easier, then just do n minus 9 times n minus 9. All right, the last one is factoring bigger by grouping, and that's when you have 4 terms. So we hopefully will get an answer when I group the first 2 and the last 2, and if I don't, then that's when we have to rearrange it like we did from the whodunit. So for this first one here, 12x to the 3rd plus 2x squared, the GCF, for the numbers would be 2, and for the variables, it would be x squared. So that's going to come out first, and then in parentheses, when I divide by 2x squared, what do I get here? 6x plus 1. Negative 30 and negative 5, the GCF for that one, would have to be a negative value, specifically negative 5. So when I go ahead and put negative 5 outside, and I divide by negative 5, negative 30 divided by negative 5 is positive 6x, and a negative 5 divided by a negative 5 is positive 1. And then this is what we want to happen, right? So what's going to happen is I'm going to bring this out, and it's going to be 6x plus 1. This is what a lot of you forgot to do. So if I cover this up, I'm left with 2x squared there on the left, minus 5 on the right. So there is my factored form for by grouping. All right, let's try, this next one here, 25t to the 3rd plus 5t squared is grouped, positive 30t and positive 6. So for this one here, my GCF, I would assume is 5t to the 2nd. So we're going to put that on the outside. Let's see what's in the parentheses when I divide by 5t to the 2nd. 5t is left, plus 1. So my objective is to get 5t plus 1 in the second set of parentheses. So this GCF looks like it is 6. So let's take out a positive 6. And now what's left in the parentheses there, divide by 6, I get 5t plus 1. Again, this is what you want. What happens to it? It comes out, right? So you have 5t plus 1. And then when that's gone, you pull it out, what's left is 5t squared plus 6. All right, last question there. I'm going to rewrite it. 28v cubed plus 16v squared minus 21v minus 12. All right, we're going to factor by grouping. Okay, let's take a look at the first one there. GCF 16 and 28. I believe that's going to be 4 for the two numbers. And then v to the 2nd for the variables. So we do 4v squared. Now let's go ahead and divide these by 4v squared. So I have 7v plus 4. And now for negative 21 and negative 12, that's going to be a negative 3 for the numbers. So let's get negative 3 out here. Divide by negative 3. I get positive 7v, positive 4. Again, this is what we want to happen. So what happens? It comes out. And what's left when I take away 7v minus 4 is 4v squared minus 3. So there is the factored answer for that last one. So the rest of the problems, the answer key is online. Please practice again on Sunday afternoon or Sunday morning before the Super Bowl. Practice this again, the whole sheet without looking at it, and see if you can get how many right, okay? And just let me know if you guys have any type of questions. Just email me.